Hello dear students, welcome to the eMath learning platform for the solutions to online assessment 1. In this case, we are specifically going to look at the section B type questions. So let's begin with question 11. So question 11 says the points A, negative 2, 1, B, negative 2, 4, C, 1, 4, D, 1, 1 are vertices of a square ABCD. The images of A, B, C, and D under a reflection in a line x minus y equals to 0 are A prime, B prime, C prime, and D prime. A prime, B prime, C prime, and D prime are then mapped onto points A double prime, B double prime, C double prime, and D double prime respectively under an enlargement with scale factor 2 and the center of enlargement being the origin. Part A, write down the matrices for the reflection and enlargement. And part B, find the coordinates of the points. Roman 1, A prime, B prime, C prime, and D prime. Roman 2, A double prime, B double prime, C double prime, and D double prime. Part C, determine the matrix of a single transformation that would map A, B, C, D onto A double prime, B double prime, C double prime, D double prime. Then finally, part D, show the square A, B, C, D and its images on the same axis. So let's begin by looking for how to obtain the matrix of transformation for a reflection along the line y minus x equals to 0. Remember, line y minus x equals to 0 is also as good as line y equals to x. That is, if you move x to the right hand side. And so you have to first draw that line. As you see it here, I've drawn it. Then what you do, you take 1 unit on the positive x-axis. So you simply take 1 unit on the positive x-axis and you also take 1 unit on the positive y-axis. At this point, I'm taking a point I, which is 1, 0. And at this point, I'm taking a point J, which is of course 0, 1. Then what you're going to do, we're going to reflect each of these points along this line that we have here. Now, for example, if you reflect this line, if you reflect this point, which is 1, 0, along this line, automatically the image of I is going to be at point J. There are two ways of locating for the image of this point here. One of the ways is you simply measure the same distance from this point to the mirror line, then you measure the same distance behind the mirror line. So it gives us the same distance at point J. So it means the image of I will be at J. And so I can conclude that actually I prime is also going to be 0, 1. Another way is simply by counting. For example, I can count from here 1 square, 2 squares. When I reach the line of reflection, I now count horizontally the same number of squares. I now count 1, 2. So I still remain at the same point. So I can now conclude by saying that I prime is actually also at the same point here. So I can indicate my point I prime, which is the image of I. Then do the same for J. Also for J, automatically the distance from J to the mirror line should be the same as the distance from the mirror line to where its image will be. So if you look at this critically, the image of J will also be at the same point with I. Or you can also count. From here, I can say 1 square, 2 squares. When I reach the mirror line, I stop, then count downwards. 2 squares, 1, 2. I still keep at the same point, which is I. So it means the image of J, which is going to be called J prime, is also going to be at, this is supposed to be 1, 0. So we can try to adjust this. So this is 1, 0. So you realize that J prime is 1, 0 and I prime is 0, 1. Now, your matrix of reflection is going to be based on I prime and J prime. So it means it is going to be 0, 1, then 1, 0. That is how we are going to obtain this matrix that I'm going to write down. So we are going to say that the matrix of reflection is going to be the matrix of reflection 0, 1 and 1, 0. Remember, 0, 1 was a coordinate obtained from I prime and 1, 0 was a coordinate, these are coordinates obtained from J prime. So the coordinates of I prime and J prime help us to come up with our transformation matrix. And that is why we are saying that our matrix for reflection is going to be 0, 1 and 1, 0. Then when it comes to enlargement, they told us that the center is 0, 0. Remember, in your notes with your teachers, they should have told you that for any enlargement from the center being the origin, if the center is the origin, then the enlargement scale factor will take up the major diagonal of your matrix, and the minor diagonal will be taken up by the coordinates of the center. And in this case, specifically, it should be the origin. That is why we are saying 0, 0. These ones represent the coordinates of the center, and 2, 2 representing the coordinates, representing the enlargement scale factor that was mentioned in the question. Remember, they told us the enlargement scale factor was 2. So from this point, we can now say we answer part B. Now remember, they told you part B, if we go back to our question, if we try to go back to the question, they said part B, find the coordinates of the points A prime, B prime, C prime, and D prime. Now, when you look at this, you're going to realize that actually you have to apply the formula transformation matrix times the object gives you the image. Now, this is our first transformation matrix, which was a reflection. So we multiply it by our object matrix. Now, the object, this coordinate negative 2, 1, the coordinates negative 2, 1 are representing A. Negative 2, 4 representing B, 1, 4 are representing C, and 1, 1 representing D. So we are simply going to multiply these two matrices. So you multiply a row by a column until you finish up. And when you finish up this, you will come up with A prime being 1, negative 2, B prime being 4, negative 2, C prime being 4, 1, and D prime being 1, 1. So how do you conclude? You automatically have to conclude in terms of coordinates. So you say A prime is 1, negative 2, B prime is 4, negative 2 in a coordinate form, C prime is 4, 1, and D prime is 1, 1. So that answers part B, but Roman 1. Then for Roman 2, we are still going to now look for the coordinates of A double prime, B double prime, C double prime, and D double prime. But remember, this time round, the transformation matrix we are going to use is going to be the matrix that we obtained from enlargement, which is 2, 0, 0, 2. And our object is now going to be A prime, B prime, C prime, D prime. So when we multiply the transformation matrix by the object matrix, we also expect to get the image matrix. So you're going to still multiply a row by column, a row by column, a row by column, until you end up with this column here. And of course, when you do the multiplication correctly, you will get A double prime with 2, negative 4, B double prime with 8, negative 4, C double prime with 8, 2, D double prime with 2, 2. Then automatically you write them in coordinate form as you see them here below. Then we can look at part C. But we can first get back to the question. What do they want exactly for part C? Part C, they said, determine the matrix for a single transformation that would map AB, CD onto A double prime, B double prime, C double prime, and D double prime. What do we do here? Here we simply say our transformation matrix, which should be the overall transformation matrix, is going to be the second transformation matrix, which was obtained from enlargement, multiplied by the first transformation matrix, which was obtained from reflection. Please, the order has to be respected. You have to begin with the second transformation matrix, T2, multiplied by the first transformation matrix. When you change this order, automatically you end up getting wrong answers. So you will simply multiply these two matrices. So you multiply a row by column again, and that will give you 0, 2, 2, 0. So when you get that, you will have got a matrix that maps A, B, C, D to A double prime, B double prime, C double prime, and D double prime. Then I think part D asked us to represent, if you go back to the question again, it told us to represent A, B, C, D and its images on the same axis. Now let's go on a graph and do this representation. So let us try to see how to show all the three figures on the same graph. Now as a student, you have to mark all these points and label them. But for me to make the video shorter, I am going to go directly. Maybe let me first create this perfect box here. Let me create this so we can have our graph come out neatly. I can try to make it bold. Okay, there we are. There we are. Now, maybe the color can also try to make it resemble the others. Can take it to green. That is now perfect. Good. Now I'm going to begin with point A. Point A is negative 2, 1. If you go back to the question, negative 2 will be here if I'm using a scale of 1 centimeter for 1 unit. 1 centimeter for 1 unit, that is the scale I'm going to use. So it means negative 2, 1 is automatically going to be around here. Negative 2, 1. Remember our origin at this is at this point. Then we go to point B, it is negative 2, 4. Negative 2 is still here. Then 4, we shall count 4 squares or 4 boxes, the big ones. And it will be at this point. So it means if I'm to plot, I will have it here. Then we go to point C, which is 1, 4. 1, 4. 1 is somewhere here. Then 4 will automatically be around here. So it means we are going to plot our point around there. Then we go to point C, point D. Point D. And point D is 1, 1. So it means I will be plotting at some point here. So I can now have my point there as point D. Of course, the next thing is going to be, I can label them. We started, remember, with point A. Our point A was negative 2, 1. So that is point A. Point B was negative 2, 4. So this is point B. And point C, we had the positive 1, positive 4. And finally, point D, we had 1, 1. So I've labeled. So it means I can now freely join the point to form a square ABCD. So joining, I can try to join. So we have point B to C. And also join C to D, join D to A, and probably, let me first try to rectify this. This line seems to be a little bit bent, yes. So let us make it more visible. Okay, so we have that. We have that. We also have this. I think this is now very clear for us. And we have C to D. Yeah. Except I think this is not a good line for us. It should be perfectly this, yes, something like that. Okay. So we have that. And finally, we have that. So that is our ABCD, which is our square. Now we can also go on and look at the image. A prime is 1, negative 2, as we had found earlier. So 1 is automatically here, negative 2 is somewhere here down. So it means our point will be there. Then we go to B prime. B prime we got 4, negative 2. 4, negative 2. So it means we're going to count 1, 2, 3, 4. Negative 2, it will be at this point. So it means I can plot at that point there. Then we go to C prime, which is 4, 1. So we say this was a prime. A prime I can label directly such that we save time. B prime we got this. And maybe we can now go to C prime. C prime, remember we got 4, 1. So 4, 1 is going to be simply 4, 1. So it will be above here. It will be above here. So I will plot at 4, 1, 4, 1, 4, 1, 4, 1. Now we don't have our line, but still that can help us out. 4, 1 is still there. Then if we go to the final point, which was D prime, it was 1, 1. 1, 1 still comes to the same point here. 1, 1. I think if you can look at D prime, it remains at the same point with D. So D prime will also be here. So it means I can simply say C prime. C prime is this here. Then D prime also shares with D. So I can indicate it somewhere there. Yeah. Yes. So we can also join them to form our square. Yeah. So I'm going to join D prime to A prime to B prime, B prime to C prime. Oh, this is a little bit bending, so you can start the process. Okay, that is now okay. This is also okay. I come to this, that is also okay, perfect. Then automatically we shall have that. So we have our other triangle. We can try to edit that a bit. Sorry for this, but that is just to make us have the best illustration. Okay, maybe can we make it appear dotted? Yes, we can, such that we differentiate between the two. Okay, that is our A prime, B prime, C prime, and D prime. Then finally we can go to A double prime, B double prime, and C double prime. Remember, A double prime was 2, negative 4. A double prime was 2, negative 4. So it means we are going to be at 2 here. Then negative 4 is down here. So it means we're going to plot at this point here. So I can now pick one of my points. And we are sure we are putting at 2, negative 2. I mean 2, negative 4, I beg your pardon. Then we go on. B double prime was 8, negative 4. 8, negative 4. I hope we have enough space. Yes. 8, negative 4. 8, this is 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Then negative 4. So negative 4 will be down here. So it means we are going to be having a point at this point. Hope that is where we are. Yes, 8, negative 4. 1, 2, 3. Sorry, this is 4, 5, 6, 7, 8. Yeah, perfect. That is okay. So actually it means our A prime, we have already, A double prime I mean, is already here. B double prime is also going to be here. Then let's look at C double prime. C double prime is 8, 2. 8, 2, it is going to be somewhere here. 8, 2 is going to be somewhere here. So it means I will have a point 8, 2 somewhere here. Yes, that is okay. 8, 2. Oh, it should be here. Yes. I think these points we can remove them so that they don't confuse us. We can remove these other points here. Yeah. Then finally we had the C double prime, I mean D double prime. D double prime was at 2, 2. 2, 2. I have a 2 where yes, 2 is here, and 2, 2 will be somewhere here. Okay, so there we are. Now I can label C double prime, remember, was this, and D double prime was this. So it means if we are now join them, you realize A double prime, B double prime, C double prime, and D double prime is bigger than the others simply because there was an enlargement. Good. So I can join them, together. So we have that to that. This, oh, sorry for that. Can begin afresh. So D double prime to A double prime. A double prime, we are joining it to B double prime. B double prime, we are joining it to C double prime. And C double prime, we are joining it to D double prime. Maybe to just make it look different from others, I will also make it appear as if it is dotted here. Maybe I can also even change the color such that they can differentiate between them. So which color can we use? Maybe you can try to use something like red, yeah. So now I have all my 3 figures represented on the same graph. And this is exactly what you were expected to do. Let's move on to the next. So number 12 says, given that A and B are centers of the circles, lines PA and PB are tangents to the circles respectively. PQ equals to 30 centimeters, while AB is a perpendicular bisector of PQ. Okay, and they're saying find the area of the shaded part which is common to the 2 circles. Very good. Now what we're going to do here is I'm going to only emphasize on this region is here. Remember, we're looking at the shaded area, but this shaded area has 2 sections. There is this small section cut off by this bigger circle, and there is also this section cut off by the smaller circle. So what I'm going to do, I'm simply going to take a sector. For example, APQ, the whole of this sector, I'm going to join A to Q. Then I will have P, of course, this curved part, the arc PQ has to still be included, and get the area of only this part which is cut off by the biggest circle. Then do the same for the small circle. So it means I'm also going to take a sector B, PQ, with also arc PQ included. Then I also join Q to B to be able to get the area of this shaded part cut off by the small circle. Now let's look at the solution. So I'm beginning with the bigger circle. Now when you look at the bigger circle, let's look back to it. If this distance is 28 AP, automatically distance AQ is also going to be 28 because they both represent the radius of the bigger circle. Then automatically they gave us PQ. They gave us distance PQ as 30 centimeters. So that is what you see represented here. And the other section that was shaded, which was cut off by the bigger circle, is this section here of shaded. And now you're going to realize that we're going to be required to look for this angle here. But why do we have 2 theta 1? What I did is I divided this triangle APQ into 2 equal parts. In other words, I simply drew a line of symmetry here. Then after having that line of symmetry, I am sure that this distance has been divided by 2 to give me 15. But taking, let me say I took AP is still 28. So it means I can be able to have a half of this angle because I've divided the angle by 2. In other words, I've bisected it into 2 equal parts. So that is why I have theta 1 here. Now, if I can get the value of theta 1, then automatically I'll be able to get the value of 2 theta 1, simply because this angle is twice this angle. So how are we going to get this theta 1? Using SOHCAHTOA. So we shall say the solution, sine theta 1 is equals to the opposite out of the hypotenuse, which is this. Then you simply take the sine inverse to get theta 1, and that gives you 32.39 degrees. Now the required angle that we want is 2 theta 1, which is the whole of this angle here. And if you get 2 theta 1, it will be 2 times 32.39, and that gives you 64.78 degrees. Now that we have this angle, we are going to get the area of all this sector, the area of the whole sector. Then we subtract the area of the triangle APQ. If we do so, we shall have got the area of the shaded part. Then we shall do the same thing to the smaller circle after the extraction. So let's move on to the next step. So now we are saying that area of the sector, remember it's given by the formula theta out of 360 times pi r squared. But remember the theta we are talking about is the angle which we represented as 2 theta 1. That is why I've substituted 64.78 divided by 360. Of course, they told you to use pi as 3.14. Then we multiply by the radius, which is 28, but squared. If you compute that clearly, it will come to 442.900 centimeters squared to 4 decimal places. Then we can now get the area of the triangle APQ. From trigonometry, we said if you already have two sides, maybe you can get back to this. If you look at this triangle here, we already have two sides, AP and AQ, but we have one of the angles. So it means we shall look at distance AP, which is going to be small q, then distance AQ, which is going to be small p, simply because it is opposite to this angle P. Then we take the sine of this angle that we have just found out. So that will lead us to the area of the triangle APQ. So by substitution, P is 28, Q is also 28, then sine of 64.78, and that gives you 354.6339 centimeters squared. Then let's look at the area of the shaded portion. The area of the shaded portion, like we said, will be the area of the entire sector, which we got as this, and I've just ignored the two zeros here because they don't add on much, minus 354.6339, and that difference comes to 88.3461 centimeters squared if you carefully press your calculator. Let's look at the other second case. So we're going to just repeat the same thing we have done in the first case, simply because we have also obtained this small sector from the small circle that we had in the question. We can go back to it and briefly look at it again. So our question was this. So what I'm going to do again is take P, B, Q together with the arc PQ. So it means it will help us to get this area here, this one, part of it that is cut off by the small circle. So that will lead us to the same procedures that we used in the first case. So it means we are going to say, we have our figures here, well drawn. So this is now 2 theta 1, sorry, 2 theta 2, because I called a half of this angle to be represented by theta 2. And this is 30, so it still comes to 15 if you divide by 2. Then 20 is the radius, which I've taken as 20 centimeters for PB. So we shall also look for theta 2 again. After looking for theta 2, we multiply it by 2. So that will be our next step. So sine theta 2 is going to be 15 out of 28 using SOHCAHTOA. Automatically theta 2, I beg your pardon, this should be theta. Yes, so theta 2 equals to sine inverse of 15 out of 20, which gives us 48.59 degrees if you press your calculator to 2 decimal places. Then automatically 2 theta 2 will be 2 times 48.59 degrees, which gives us 97.18 degrees. Then we still get the area of the sector using the same formula we used in the first case. Remember, our angle is now 97.18 divided by, because you divide by 360 times 3.14 times 20 squared. And this gives you 339.0502 square centimeters. Then we also get the area of the triangle. This time we're looking at the angle at B, so that is why we have sine B, but PQ still remain there because they are the sides that we have. So if you do the substitution, it will be a half into 20 into 20 sine 97.18 degrees. and this gives us 198.4317 square centimeters. Now the answer or the result we are looking for is the area of the shaded portion, which is still the difference between the area of the sector, which is this, and the area of the triangle. That is why we are subtracting this value from this value. And if you do the subtraction correctly, you will get 140.6185 centimeters squared. Then from this point now, we are going to proceed and get the total area for the shaded part of the figure. So the total area of the shaded part will automatically be the two areas that we have obtained. We simply add them, and when you do so, you come up with something related to 228.9646 square centimeters. So that gives you all the marks for that question. Let's go to question 13. They're saying a radio is offered for sale at shillings 80,000. Cash or deposit of 12% of cash price plus 9 monthly payments of shillings 9,400. Calculate the cost of the radio under hire purchase from to the amount of money saved if the radio is bought for cash rather than hire purchase. Good question. And part B, a man deposits shillings 50,000 in a bank which offers a compound interest rate of 12% per annum. How long will it take him to accumulate the interest of shillings 12,720? Good question for us. So this is under business mathematics. Let's look at the solution for this. In the first case, when you talk about hire purchase, they gave us conditions in the question. They told you that you have to first make a deposit of 12% of the cash price. So the cash price was 80,000. When you get 12% of 80,000, you come up with shillings 9,600. That is what you have to first deposit. Then on top of this, now they told you that you're going to pay this amount. You're going to pay 9,600 plus. They also talked about some amount here later. Yes, they mentioned 9,400 shillings, and they said this will be for 9 months. So that is why in the solution we multiplied 9,400 by 9. So that will be the total amount the person would pay to get that radio. I hope it is a radio, yeah, at hire purchase. Now that gives us shillings 94,200 if you multiply well and add. So the amount saved, because they also asked us for the amount saved, automatically it will be the amount for hire purchase minus the amount for cash basis. Remember, if you had cash, you would simply pay 80,000 and take the item. But here for hire purchase, you're paying as much as 94,200. And so if you get the difference, it comes to around shillings 14,200. That is the money that would be saved. Then part B it was compound interest. But remember, they told us that this person deposited 50,000, and they're asking us for how long it would take the person to earn the interest of 12,720. So it means the total amount the person will earn in that time that we don't know will be the amount he deposited and the interest. And if you add this, it comes to 62,720. And after this, now we use the formula which says amount equals to principal into 1 plus the rate out of 100 power n. Now if you substitute in that formula, the amount is 62,720, principal is 50,000, and our rate was 12. So you come up with this step that we have. Then from that level, if you can add 12 out of 100 plus 1, you will get 1.12 power n. And from here, we need to look for the value of n. What are you going to do? We are simply going to think about logarithms at some level. We're going to think about logarithms. Now, when you look at this value that you see here, 1.2544, it was obtained by simply dividing this value here by this value here. And after that, Automatically, now we have to think of introducing log base 10 on both sides. So I introduce log base 10 on both sides, and automatically n being a power, we shall transform it to this position such that we have n log this equals to log this. But to make n the subject, it will automatically be log of this divided by the log of 1.12. And if you press this, you will get n as 2 years. So it means that person will take around 2 years for him to accumulate the given interest in the question. Let's move on to the last question, and that is question 14. They're saying 3 people, Paul, Mary, and Simon, contribute towards a saving fund. If Paul contributes 3 out of 5 of the total, Mary contributes 2 out of 3 of the remainder, and Simon contributes shillings 8,000. Find the total amount of the savings fund. Roman 2, contribution made by Paul and Mary independently. And finally, they told us to use logarithm tables to evaluate this. Now let's begin with part A of the question. So the solution for that. So let's go step by step such that we don't get confused. Now remember, they told you that 3 out of 5 was a fraction that was contributed by, we can check through the question. It was a fraction that was contributed by Paul. So if Paul contributed 3 out of 5 of the total, what does it mean? It will mean that our remaining fraction will automatically be the total fraction, which is 1 minus 3 out of 5. And that gives you 2 out of 5. But remember, they said Mary contributed 2 out of 3 of the remainder. But what are we talking about here? The remainder, remember, was the 2 out of 5 in terms of a fraction. So when they say of, automatically it means multiplication. That is why I'm getting 2 out of 3 multiplied by 2 out of 5. And that gives us 4 out of 15. Now that we know the fraction that Mary contributed, we know the fraction that Paul contributed, it means we can now get the fraction for Simon by simply saying 1 minus 3 out of 5, that is for Paul, and minus 4 out of 15, that is for Mary. If you simplify this with your calculator or using the LCM, you get 2 out of 15. So what does it mean? Remember, they told you that Simon contributed 8,000 shillings. Now, assuming the total amount for the saving fund was X, it means the fraction of Simon, when you get it and you multiply it by the total amount, it should be giving you 8,000 shillings. So 2 out of 15 of X means 2 out of 15 times X, giving you 8,000. So if you multiply 2 by X, that will be 2X out of 15. And if you cross multiply and divide, you will get the value of X as shillings 60,000. Then from this level, we shall say Paul. Paul now contributes 3 out of 5, which we knew earlier on, it was here, but times the total amount, which is 60,000. That gives you 36,000 shillings. Then automatically Mary contributes 4 out of 15 times 60,000, which is the total, and that gives you 16,000. Now you have to ensure that when you add these 3 amounts, they should all add up to the total amount, which is 60,000. And indeed, when you add 16,000 plus 36,000 plus 8,000, you will get your 60,000. Let's look at part B. Part B, they talked about logarithm tables. They wanted us to get the cube root of 0.7196. Now, 0.7196 as a number, before you talk about the cube root, can be written as 7.196 times 10 power negative 1. And under logarithms, you write 1 bar 0.8571. Then cube root now means 0.7196 power a third. So we simply get that power, which is a third, and we multiply by the logarithm that we obtained in the first step here. That is why we have this step here. Then we have to simplify this by breaking it down into 3 bar plus 2.8571 divided by 3. And that gives you 1 bar 0.9524. Then when you're getting the ant log, you simply get the ant log of 0.9524. Then you multiply by 10 power negative 1, simply because we have 1 bar here. When you do this, you get 0.8962. So this brings us the end of the solutions to the section B type questions. So I think with the few challenges, I will be able to upload the next video that will be containing assessment 2 tomorrow. Have the